So besides this in operator and the exists operator, another important operator we want to introduce here is called any, the any operator. It is also a comparison operator. It compares a tuple versus a relation. It is a Boolean condition, meaning this x equals to at least one tuple in the relation. We can use x equals to any with a relation, right? It means this x equals to at least one tuple in the relation. And this equals can be changed with some other comparison operators. We can use this larger than or no smaller than some other operators. It denoting a comparison between a tuple versus a relation, right? So we provide you with the example like x is no smaller than any of a relation, means x is not smaller than some tuples in the relation. If we can find one case, make this condition holds or legal, then we will return a true value. Otherwise, we can return a false value. Also, please be careful. We also need to ensure this tuple contains one single column or one single component only, because we're doing a comparison. We need to make sure this x it has one single column. Similar for this relation, it contains one single column, so we can do the comparison like equals or no smaller than as shown here. Besides the any, another operator will be which is very similar is called the or operator. This or operator is very similar to the any, however it conveys very different semantic meanings. The grammar for this or operator is very similar. We can use like x not equals to or of a relation. It can return a true value if and only if for every tuple t in the relation, x is not equal to t. You can also compare with this any, right? For the any, if we can find one case, make this condition holds, it will return true value. However, for the or, this operator, we need to make sure for all the cases, its comparison doesn't hold, then we can return true value. In other words, its semantics meaning for this x not equals to or relation, denoting this x is not a member of a relation. And this not equals to this operator can also be replaced some other comparison operators as well. For example, we can use this x is no smaller than or relations. It means there is no tuple larger than x in a relation. I hope you still remember in the homework 2, as well as previous slides, we have one question to find the highest value of a relation, right? I hope you still remember how we do this question before, right? With both relational algebra as well as SQL. Here we can do this question in a much simpler way by using this or operator to help us. We have a question as shown here. From a sales table with bar beer price, please find the beers sold for the highest price in the table. How can we do this question? Before we can do this question by using the sales table twice, right? We can use sales S1, sales S2, and then do some comparisons. However, here we can do it in a much simpler way. When we see a question like this, the first sub-question in our mind will be, what is the highest price appearing in this sales table? Right? What is the highest price? So we can denote the highest price of all the beers in this sales table as we have all, we have parentheses, this is a subquery, right? In this parentheses, we have select price from sales. This subquery will return what? We return all the price in the sales table, right? And then we can do a further comparison. Where price is no smaller than or of the subquery. It denotes what? It denotes this price is no smaller than all the values inside the subquery, right? And these values inside this subquery denoting all the prices in this sales table. So it means this price is no smaller than any price in the sales table. In other words, this price will be the highest price in the sales table, right? Then we can do the select from where statements outside. We have select beer from sales table where price is not smaller than or the price inside the subquery. Okay, in this one we can do this. We can answer this question in a very different way. You can compare its expression versus the one we write before. Right? This one will be easier for you to understand, I think. So this or and operator can be very useful for us to write some queries to help us. So we have two different semantics in the select from where queries. This SFW denoting the select from where, the statements we write before. So these two semantics denoting this back versus the set semantics of his select from where queries. The main difference between them lies in these duplication records. Before, the select from where this statement uses back semantics. If you still remember in the relational algebra, we have talked about some operations, right? The selection, projection, product, and joins. Remember, for these operations, we never eliminate these duplications. We now duplicate records in the results. Therefore, when we say these operations uses the back semantics, because it announce these duplications of the tuples. As comparison of these back semantics, we also have this set semantics. If you still remember, for sets, we don't allow these duplications, right? So the default for the union, intersection, and difference uses the set semantics. And it is expressed by the following forms involving subqueries. By using this union, intersection, and except, and difference, we can just connect multiple subqueries together to do either join, either or the cap, or the difference. Now we can write down a subquery in a parentheses, union a subquery in a parentheses. Then we can union the tuples in these two subquery return results together. So remember, for the unions, we use the set semantics. In other words, for data tuples appearing multiple times in these two subqueries, they will be eliminated, and we can only keep one single record. Similar for the intersection and the difference. So for the back semantics, we allow duplications. For set semantics, we don't allow duplications. We eliminate some of these duplicated records automatically. So these two semantics can be very important because they can provide you with different results when you're doing your project or doing your questions. If you don't know the differences, you can get very surprising results, which is not expected by you, right? We can provide you with some examples.